All right, so 6.4 is actually putting together a lot of the things we've been doing in the last 3 sections, okay? We're going to look at ratios, proportions, and proportional reasoning. And first, I want to talk about what those words kind of mean for us. Ratio notation has 3 different forms. You can write it with a semicolon between it, you can write it as a fraction, or you can write it in words. But any way that you write it, it's read A to B. A is to B. So it's a comparison is what a ratio is. A ratio is a comparison. There's a couple of ways to do a ratio comparison. One of them is a part to whole, and the other is a part to part. So there is an example here. It says if there are 15 students and 7 make an A, then the ratio of the part, that is the number of students who make an A, to the whole would be 7 to 15. Okay, so that's the number of students that make an A compared to all the students. But if you compare those as the number of students who make an A compared to the number of students who don't, that would be 7 to 8. Okay, so you can either compare part to the whole or you can compare part to part, the 2 parts together. Either one are ratios. So if you take a look, and you can find them from each other, and that's what we're going to do on examples 1 and 2. So in example 1, it says if the ratio of boys to girls in a class is 2 to 3, what is the ratio of boys to all of the students in the class? Okay, so how do we get from 2 to 3 to 2 to 5? Right, and I'm going to show it to you like this because this is what you would want to explain, or one way to explain if you were working with the younger kids. So there are 2 boys compared to every 3 girls, right? And what we want is we want to compare the number of total boys, the 2 boys, to the number of total kids, or to the number of kids total, which was 2 boys to every 3 girls. And this is the total number of kids, at least in the ratio. So this would be 2 to 5. And you can write it like this or like this. Okay. Sort of easier to think about when you say it, when it's written the second way with the semicolon, but it's easier to work with in terms of working a problem when it's done in fractional form. You can go the other direction, though. If 3 out of 7 of the class are girls, then what is the ratio of girls to boys? Okay, so we can set up the same kind of a ratio description. We can talk about 3 girls to 7 kids. But kids are created of what kinds of kids in this description? Boys and girls, right? Well, we knew that 3 girls are the 3 girls down here, so how many are the boys? There's 4 boys. So this is 3 compared to 3, I'm sorry, the way I wrote it, 4 plus 3. So here's my boys, and here's my girls. So if I want to compare boys to girls, or in this case they wrote it as girls to boys, it would be 3 to 4. Does that make sense? Okay. Show me something that indicates what you're doing. Some of you are jumping to the answer already, and that's great, but just show me something of how you would explain if you were working it with someone, okay? Somebody who didn't understand it and you wanted to show them how you were thinking about it. All right, this leads us to proportions, which is kind of the big point of this particular section. A proportion is simply an equality, an equation that compares 2 ratios, okay? So we have 2 ratios, A over B and C over D, and a proportion simply says that they're equal to one another. And we have 3 different theorems that are wonderful theorems about how you can work with proportions. So let's take a look. We have that A over B equals C over D, and if we have that proportion, it is equivalent to having that same proportion cross-multiplied. So that's the actual language you guys keep using when you're talking about adding fractions. That's not really cross-multiplying. But I understand what you're doing, because what you're doing is exactly visually what they're doing here, right? You're looking at the crosses on this multiplication problem, or on this equality, and you're actually doing the multiplication. So it's equivalent to say that A times D equals B times C for a proportion. That's the one that you're familiar with and you use it a lot. But notice, if you have a proportion A over B equals C over D, it's equivalent to take those 2 fractions and do what with them? Flip them upside down, right? I can just turn those two ratios upside down and the equality is still the same. And if you aren't for sure, take a look. Look at the cross multiplication. It's still b times c, and it's still a times d, just like it was before. So you just flip the fractions upside down, you have an equivalent proportion. But not only can you simply flip the fractions upside down, what happens to this one right here in Theorem 622? How does this proportion a over c equals b over d compare to a over b equals c over d? What's changed? The b and the c switched spots, right? These guys switched places. That wasn't good. But take a look. Doesn't it still work out the same if you cross multiply? You still have b times c, and you still have a times d. So it's perfectly fine that you switch the diagonals. In fact, if you so desire, you could switch both diagonals. All right? Now, I mentioned this for a couple of reasons. One of the reasons I mention this is because when you set up proportions, there's often multiple ways of thinking about setting them up that will come to people differently. And they still all work. And they still all work partly because of these theorems. Okay? So let me do some examples with you so you can see what I mean by that. Jim found out after working for 9 months, by the way, he should have known this before he ever took the job, but he didn't. After 9 months, he found out that he had earned 6 days of vacation time. Question is, how many days per year does he earn if he's doing it at this rate? Now, I'm going to say this once. I'm sure I'll say it again too, but everything you do in this section should be done using what? Proportions. Okay, proportions. So there's more than one way to do the problem, and I understand that. But proportions are emphasized really early in mathematics for children now because they're able to be set up so much more intuitively than equations. And I understand proportions and equation, but equations with x is equal to this variable and things like that. So everything you do in this section better look like a proportion or you won't get any credit for it. All right? You have to use proportions. That's the point. Hence, ratio and proportional reasoning, the description of the section. So, we're going to set up a proportion, which means we are going to have something equals something, and there's going to be fractions involved. That's what we're going to have. So, what kinds of things are we comparing? What are the comparisons being made in this situation? The days of vacation compared to the months of employment, right? That's the comparison. You can either set up one side to be days and the other side to be months, or you can set up that the numerator is days and the denominator is months. It doesn't make any difference, so somebody pick one for me. Okay, Shannon wants to do months on the left. Is that okay? Okay, so we're going to do months over here. That is how many months he's worked, and then we're going to do our days of vacation over here. Okay. So what is one of the months descriptions that we have? 9 months. So in 9 months, how many days of vacation does he get? 6. So the equivalent is the 9 months in the numerator would be equal to 6 months or 6 days of vacation in the other numerator. They go together. So they're going to be in the same location in the two fractions. Okay? What's the other months that we're talking about? 12. Okay, we got to keep them in months, or you've got to keep the units to match up. So this is 12 months on bottom. What's the number of days? We don't know. That's what we're looking for, right? I mean, that's the whole point of what we're looking. So this is the x. This is the number of days that we're looking for. So once I have it set up, then what can I do? Cross multiply. That was Theorem 620, I think it was called. I can actually do this, and I can say, oh, 9 times x is 9x. And 6 times 12 is 72. I wrote 9. I don't know why. 72. And then we would divide by 9. 72 divided by 9 is what? 8. 8 what? Days of vacation. Does that make sense? All right. Okay, I'm going to do one more, and then we're going to do some group work. All right. On a city map, a rectangular park has a length of 4 inches. If the actual length and width of the park are 500 feet and 300 feet respectively, how wide is the park on the map? How do you want to do it? What are the comparisons being made? Feet and what? Inches. But it's not just feet and inches, it's feet of what? Okay, we got length and width. What's the comparison really being made? Between the map and actual real life, right? We've got what's going on the map, and we've got what's going on in real life. So what do we want to do? We do map versus real life, map on top, real life on bottom. What do you think?
Map versus real life.
Okay, so we're going to do map on the left, and this is real life. Can't spell real. On the right. So what do we know about the map? Well, the other thing that's being compared, Lauren was correct, is the length versus the width, right? I mean, we've got two different values for those. But the units, like Devin said, is going to be feet and inches that we're doing comparison for. So we have to keep all of that straight. Let's talk about the map first. What do we know about the map? We've got stuff about inches on the map, right? The map is in inches. And 4 inches is one of the dimensions on the map. What is it the dimension for on the map? The length. So I want to compare that to the length in real life. And what is the length in real life? It's the 500 feet, right? And they're just doing it in order, length and then width. So this is the length and then this is the width. So the other thing we know is we know the actual width in real life. So that's the 300 feet, and it better go on the real life side of the equation, right? And the piece that we don't know is exactly the piece that I don't have filled in, correct? All right, so call it whatever letter you'd like. I'm going to call it W now since I don't know the width. Just for fun, we'll call it something that's not X. What am I going to do?
Cross multiply.
Cross multiply. Okay, so I have 4 times 300. What is that? 1,200. You don't need to worry about the feet and the inches. It all lined up. It's all working out, right? Okay, in the end, I know that the answer is going to be W and it's going to be in inches. So we can ignore all the units in the middle of what's going on. Set them up in there originally, though, to make sure that you're not lining things up improperly. The other one is 500W. So then what do I do? Divide by 500. So what's 1,200 divided by 500? It's 2.4 inches. And it makes sense to report that in terms of a decimal because that's one of the ways, well, that's a reasonable way of measuring length when we're talking real life. If you told me that it was 12 over 5 inches, that would be quite awkward in a real life situation. Agreed? Okay. All right.